Welcome, geometry students, to the homework help video or the review sheet help video. Let's go ahead and get started on page 633, numbers 1 through 4, the first 4. The directions say to tell the number of faces, vertices, and edges of the solid, okay? So, now remember this, by the way. Please don't forget this. This is very helpful, okay? Are you listening? Anytime you have a solid like this, a polyhedron, you can take the faces plus the vertices, okay? And it's always going to be 2 more than the edges. So edges plus 2, okay? So remember this, this will help you, okay? Anytime you add up the faces plus the vertices, it'll always be 2 more than the edges. So please remember that. Alright, here we go. Let's start with the faces first, and here we go. There's a front face here. There's a back face here. So there's 2. And then count the ones. I'll put lines. There's 1 here, 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 and here. So we have 6 all the way around. 1 in the front and 1 in the back. So we have 8 faces. Now, the vertices would be, watch carefully, the vertices would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's the vertices, okay? So, now remember, if you add these together, you get 20. The faces plus the vertices will always be 2 more than the edges, okay? So 8 plus 12 is 20. Take away 2 from that, and there must be 18 edges, alright? So not too bad. Number 2. Alright, let's count the faces, alright? Here's 1 in the front right here. Then here's the 1 in the back right here. Okay, that's 2. That's 2. Then we have 1 right here. Then we have 1 right here. That's 1, 2. Then we have 1 right here. That's 3. And then 1 right here. That's 4. 1 right here. That's 5. 1 right here. That's 6. And 1 right here. That's 7. Alright. And then of course the front and the back, like I already counted. So a total of 9. Alright. So there are 9 faces on this polyhedron. Alright. 9. Now the edges, or excuse me, the vertices, let's see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Alright, so there's 14 vertices altogether. Now if you add 9 plus 14 together, you get 23. Then subtract 2, you'll get 21 for the edges. Okay? Remember, you can always add the faces and the vertices together and subtract 2 for the edges. Alright, number 3. We have a front right there and a back right here. That's 2, okay? Don't forget that. Then we have 1 here. Then we have 1 here. And we have 1 right here. And then 1 right here. That's 4. Plus 1 in the front, 1 in the back. That's 6. So we have 6 faces all together. Alright? 6. Now for the edges, we have, let's see here. 1, 2, 3, 4, 5, 6, 7, 8. I'm counting 8 edges. So, or excuse me, sorry guys, vertices, vertices, vertices. So 6 plus 8 is 14. 14 minus 2 is 12. 12 edges. Alright, number 4. Let's count the faces here very quickly and see how we do. Alright. We have a front right here, that's 1. And a back, that's 2. There's a front and a back, there's 2. Then we have this face right here. Then 1 right faces, if that's correct. 5 faces. Now, vertices, I have 1, 2, 3, 4, 5, 6. So we have 6 vertices. Add those two together, subtract 2, we have 9 edges. Okay? Alright, moving on to numbers 5 through 10. Now, we're going to match these up, okay? Base of the prism. Well, the base of the prism, I mean, look, guys. Here's the base of the prism right there. So as I look at my options over here, I see E, which is quadrilateral, EF, GH. So I think letter E would be for number 5. Now, lateral face of the prism. Remember, a lateral face is any face that's not a top or a bottom. A lateral face is any face that's not a top or a bottom or a base, a top or a base. So it could be any of these over here. I think ADHE works. Yep. ADHE. That's this lateral side right here. Okay. Right here. And that is a face. It's not a top face. It's not a bottom face. So it's a lateral face. So I say letter C for number 6. Quadrilateral, ADHE. Alright, number 7. The height of the prism. Now the height, of course, is the perpendicular height from the top of the prism down to which it forms a perpendicular line with the base. Okay? And so the height here is going to be X. That is the height, letter A. Now the slant height of the prism is going to be as if you were standing on this edge right here. Hold on one second. If you were standing on the edge here and you want to toss down a rope for your friend down here to climb up the edge right here, okay? And of course this slant height here will be the exact same slant height as this one over here. And that's CG. And there's CG right there. Letter F. Alright, perimeter of the base. Well, guys, the perimeter of the base is just EF plus FG plus GH plus EH. Don't you add all 4 sides together? Sure you do. So the perimeter of the base would be letter B, where you're adding up all of the edges, alright, of the base. And then number 2, lateral edge of a prism. Well, the lateral edge is where 2 lateral faces intersect, okay? So a lateral edge would be this here, or excuse me for yawning, this here, or this here, or this here. It's where 2 lateral faces intersect, okay? So it's obviously going to be letter D, because letter D is AE, which is right here. This is a lateral edge because it's an intersection of this lateral face right here and this lateral face right over here. Okay? They intersect right there, and that would be a lateral edge. Okay? Moving on to numbers 11 and 12. Draw the solid. I'm not really too worried about drawing it. Then find the surface area and the volume of the solid. Okay? So we're looking at a right rectangular prism. So I'll draw one real quick. I mean, it doesn't really matter, in my opinion. Where you put the 8, 12, and the this length here is 8, and this little length here is 18, but it doesn't matter where you put these numbers, trust me, okay? Now, in order to find the surface area of a right prism, there's a formula that we learned, okay? And so, that surface area of a right prism is, and you're welcome to have this written down for your test, of course, 2 times the area of the base plus the perimeter of the base times the height, okay? So let's first of all highlight the base. Here's the top side. Here's the bottom side right here. Right there, okay? So what we're going to do first of all is take 2 times the area of the base. Now the area of the base is going to be 96, 8 times 12. So we have 2 times 96, okay? Plus, then we have the perimeter, capital P stands for perimeter of the base. So 8 plus 12 plus 8 plus 12, okay, would give us 40. So the perimeter of the base is 40, and then the height of the prism would be this right here, times 18. That's the surface area, okay? So, what do we get? 198 plus, and then 40 times 18. 720. 918. I really feel like I made a mistake on this. And I'm back, students. I did make a mistake, and I'm glad that I checked for that. It just didn't seem like it was right. I don't know why I thought that, but right here, I did 2 times 96 in my head. It's 192. So when you add these two numbers together, you will get to 912, not 918, okay? So there's the surface area. Capital S stands for surface area, and there we go. Now let's find the volume of this right prism, okay? Well, the formula that I gave you for the volume of a right prism is volume equals area of base times the height, okay? So that's pretty simple. The area of the base is 96, we already found that out, times the height, which is 18, okay? And if we take 96 times 18, we are going to get 1,728. 1,728, that would be cubic centimeters, because we're dealing with centimeters in the problem up here. Centimeters, centimeters, and centimeters. Okay. Alright, moving on to, so that's the volume in the surface area. Moving on now to number 12. Now we have a right cylinder, okay? A right cylinder. And so the right cylinder, drawn crudely, would just look something like this, okay? It's not going to be perfect, but it's good enough. Okay, there's a cylinder. Now, we're going to do 2 things. We're going to find the surface area, and we're going to find the volume. Okay, now the surface area of a cylinder, there's a formula for that. And the formula for surface area of a prism is, let me think about this for a second. It was pi r, let's see, 2 pi r squared plus 2 pi rh. Now that's the formula for the surface area of a cylinder, alright? So what I have basically, students, is 2 times 3.14 times the radius squared. Well, the radius is 3.5, so 3.5 squared, plus 2 times 3.14 times the radius, which is 3.5, times the height, which is 8. So grab my calculator here. Let's see what we get. 76.93. And then 2 times 3.14 times 3.5 times 8 gives us 175.84. Alright, let's add these two numbers together. We're going to get 252.77. This is surface area, so inches squared. Alright, let me check the book real quick on that, make sure we did that correctly. And moving on, yes, that is correct. Now we're going to find the volume of this cylinder. Now the formula for volume of a cylinder, of a right cylinder, is pi r squared h. Alright. So students, if this is the formula that helps you find the volume of a right cylinder, then all we have to do is take 3.14 times r squared. Now the r, of course, is 3.5, and the height would be obviously 8 right here. So with my calculator very quickly, I'm getting 307.72. 307.72, and that would be cubic inches. Cubic inches because we're dealing with volume. Okay, students, moving on. That is the correct answer, so moving on. Numbers 13 through 18. Well, guys, this is really hard to see over here, and I apologize. I took 2, 3, 4 pictures of this, and I could never get it to look good, okay? So, you can look in your book and see what these are over here, okay? So, number 13, base of a pyramid. Base of pyramid. Well, here's your pyramid right here, and here's the base right here. Quadrilateral NKLM, or whatever order you want to go in, alright? So, let me look at my book here. I can't really read these myself over here. It looks like it would be letter D. Letter D is the correct answer because letter D right here is KLMN. So it would be letter D. Now, lateral face of pyramid. Remember, lateral face is any face that's not a top or a bottom face, okay? So your lateral faces could be this triangle here if you wanted, or this one over here, or this one here in the back, or this triangle here to the left, okay? Any of those would be a lateral face. So as I look at the answers here in my book, I'm thinking it's going to be letter, let's see here. I would think F because it says triangle, JKL. Here's J, then down to K, then over to L, and then back up, okay? So that is a lateral face. So the lateral face of the pyramid would be letter F. Letter F. The vertex of the pyramid is this right here, which is point J, and it looks like that's going to be letter A, alright? Now a base edge of a pyramid. Well, base edge, guys, look. LM is a base edge, NM is a base edge, KN is a base edge, and KL is a base edge, okay? So any of those would work. So as I look at the different edges here, MN, there it is. MN is a base edge. It's the edge of a base, and it's going to be letter E. Letter E for number 16. The height of the pyramid. Well, students, look carefully here. The height of the pyramid is right here in front of you. It's right here going straight down. That's like you drew a hill. You got up here, and you drew a hill, a hole right here, and then drop down a rope to here. Okay, that's going to be the height. So the height is JK. JK. And JK, of course, is C. So the answer is C. Alright, now, the slant height of the pyramid, the slant height would be this line right here. Like you threw down a rope to a friend climbing up the side of the pyramid. That's JP. So JP would be the letter B, would be the slant height of the pyramid. Alright? Okay, moving on to numbers 19 through 22. 19 through 22. say to find the surface area and the volume of the figures that are given, okay? And they are regular pyramids and right cones, as it says in the directions, okay? So, with that in mind, let's go ahead and find the surface area and the volume of this regular pyramid, alright? So, there's the two. Did not mean to do that at all. Let's go back to here and there's the formulas we're looking for right there, okay? So with that in mind, let's find the surface area first. Now, if it's a regular pyramid, that means your base is a regular polygon, okay? So with that in mind, the area of the base would be what? Well, your base is a square, a 6 by 6 square. So the area of the base would be 36 plus 1/2. Now, the perimeter of the base would be 6 plus 6 plus 6 plus 6, which is going to be 24. Now, the slant height is this height right here, so 5. Okay, so 1/2 times 24 times 5 is 60. Add those two together, and we'll get 96 centimeters squared because we're dealing with surface area. Okay, so see if that makes sense, and let's move on. Now, let's find the volume of this pyramid. So it's 1/3. Area of the base, of course, is 36. We already found that. Then times the height. Now we're missing the height. The height is this line right here. But it looks like to me we have a right triangle. Okay? So here's your right triangle coming down, over, and up. Now, we know this length right here is 5. Okay? This length right here is 5. What we need to know is the height, which is this line right here. I'm going to call that x. But look what I do know. Think about it, guys. If this whole side right here is 6, which it is, and this point's right in the middle, which it is, then that point would be equal to this point here. This line here would be what? Half of 6 is 3. That means this line right here is also 3. So now using Pythagorean's theorem, which I'm not going to do for you, because we've done tons of those, you will get 4 for x. Okay? So x right here equals 4. X equals 4. So the height right here, the height is 4. So with that in mind, we get 48 cubic centimeters. Alright? 48 cubic centimeters. 1/3 times 36 times 4. Moving on to number 20. Now this is a pretty challenging problem, okay? So let's really think this through. First of all, we have a pyramid, okay? So we're looking to use the formulas from right back here. Here. So let's grab those. And let's paste those, right? If I can get this to work. Right there. Okay, now, let's go ahead and find, first of all, the surface area of this pyramid, okay? Well, I have to find the area of the base. Now, that's going to be a challenge. This is a regular pyramid, thus I know the base is regular. So I've got sides of 4, 4, 4, 4, 4, and 4. It's 6-sided, okay? So what I have here is a six-sided base for this regular pyramid. So I'm going to draw it off to the side here, just so we can see it a little bit, okay? So it looks something like this. There we go. So, and all the sides are going to be 4 all the way around, okay? Now, if I want to find the area of this base, now listen to me carefully. If I want to find the area of this base, which is what I want to do, there's a formula for finding the area of a regular hexagon or any regular polygon, okay? And this is a regular polygon here. There's a formula I taught you guys, and it is area equals 1/2 times the apothem times the perimeter. Well, guys, we know the perimeter. The perimeter is going to be 4 times 6, 24. Because you got 4, 4, 4, 4, 4, 4. 4 times 6 is 24. Okay, that's pretty obvious there. So the perimeter is easy. However, the apothem is something else. We've got to find that. So please watch what I do. If I were to draw all these triangles right here, I would have 6 congruent triangles. 1, 2, 3, 4, 5, 6. Now, if I start right here and go all the way around to here, that's 360 degrees. Okay, do you see that? I hope that you do. So if that's 360 degrees all the way around, I've got 6 congruent angles here. Divide by 6, I get 60 for this angle right here. So guys, think about it. If that's 60 right there for an angle, I can really find the apothem. Now don't forget, the apothem is this segment right here, from here, the midpoint, to the center of the polygon, or in this case we have a hexagon. So that's the apothem right there. Put a little A right there. So I'm going to draw that triangle here off to the side. We have a big old triangle here, and we know this is 4 all the way across. We know this is 60 right here. We're going to drop a line straight down. It's going to cut this 60 in half. It's going to make this angle 30. This is a right angle here. So if this is 30 and this is 90, we know this has to be 60. Also, it cut the 4 in half. So this length right here is 2. Guys, I can find the apothem in a second. Remember our shortcuts from 30, 60, 90 triangles. This should be a 60, not a 90. Sorry about that. Look, guys, here's a 30. Go straight across, smaller leg. Here's 60. Go straight across, longer leg. Do you remember how to find the longer leg? You take the shorter leg and multiply it by the square root of 3. There you go. So I just found the apothem just like that. 2 square root of 3. Okay, so with that in mind, let's go ahead now and find the area of this base, because that's what we need right here. Don't lose sight of the trees for the forest. We're trying to find the surface area of this pyramid right here, the surface area. And if we're trying to find the surface area, step 1 is to find the area of the base. And so that's what we're trying to do. And we just about have it solved right here. Let me grab my calculator very quickly and type in 1/2 times 2 square root of 3 times 24. And we're going to get 41.569. So 41.6 is the area of the base. 41.6 plus 1/2 times perimeter of the base, which is 24, times the slant height. And they gave that to you, it's blurry, but you can see it in your book. They gave you the slant height, which is 4 square root of 3. Okay, so with that in mind, let's quickly multiply all those together and let's find the surface area. So 0.5 times 24 times 4 square root of 3 will give us 83.1. So I have 83.1 plus 41.6. And I'm getting 124.7, and that's the correct answer. 124.7 square inches, because we're dealing with surface area. Alright, now let's take a look at the volume, okay? The volume of of this regular pyramid. And here we go. Okay, the volume is 1/3 times the area of the base. Now we already found the area of the base, and I think I just deleted it, which could cause some problems here. There it is, 41.6. So 1/3 times 41.6. We already found the area of the base earlier. Now times the height, that's what we're missing. But again, we have a right triangle, guys, look. Okay. We can find that height, okay? visualize carefully. The triangle looks like this. Alright, now we know this length right here is the same as this length here, 4 square root of 3. Now, we're trying to find the height. We'll put h right here. How long is this line here? Be careful. Notice it runs from the, now watch this, it runs from the center of the base to this side right here at the midpoint. Guys, that's the apothem. Look, we just drew a bunch of, remember, this is the base that we just dealt with. Right there. This line right here, guys, is the apothem. Let me clear all that out and show you. This right here is the apothem. Right there. It goes from here to the midpoint of the side. So the apothem was, what was it? 2 square root of 3, I believe. Okay, so guys, using Pythagorean's theorem, and I am going to work this one out for you, but using Pythagorean's theorem, we can find the height and then put the height right here. So we have a leg squared plus a leg squared equals hypotenuse squared. Alright, well, h squared is h squared. Now, when you square this, you square the 2, which is 4, and you square a square root of 3, which is 3, and then you multiply those two together. You square the 2, which is 4, you square a square root, which gives you 3, multiply those together, and you'll get 12. Over here, you square the 4, which is 16, and you square the square root, and you get a 3, and those ought to be multiplied together. 16 times 3 would be 48. Alright, now bring the 12 over and make it a negative 12, and that would leave you with 36. Take the square root of both sides and we get 6 for the height. Okay, so grab my calculator very quickly. I'm going to take, let me clear my screen off here, 1/3 times 41.6 times 6, and I am getting 83.2, and the answer is 83.1, so definitely close enough. 83.2 inches cubed, because we're dealing with volume. Alright, moving on to number 21. Number 21, alright, we're going to find the volume and the surface area of a cone. Okay, students, number 21. They want us to find the surface area and the volume of this cone. And so let's get our formulas up here. There we go. Alright, surface area, first of all, of a cone is pi r squared plus pi r l. L being the slant height. So pi is 3.14. The radius would be 4. So we have 4 squared plus 3.14 times the radius, which is 4, times the slant height, which is 10. They give you the slant height right here. Okay, right there. Alright, now, moving on. So grab my calculator here. 3.14 times 16, because 4 squared is 16, would give us 50.24. And then 3.14 times 4 times 10 would give us 125.6. Now add those two together, and you come up with 175.84. That's surface area. So centimeters squared. Okay, let me check that answer real quick in the back of the book here, and we will continue on. Next, we're going to find the volume, and yes, that answer is correct. Now, moving on to the volume of this cone. The volume, well, we have the formula in front of us, so it really shouldn't be too difficult. 1/3 times 3.14 times the radius squared, so times 4 squared, times the height. Now, they don't give us the height, guys. Here's the height, and it's missing. So, see this edge of the cone right here? The slant height, that's 10. Well, if that's 16. 10 times 10 is 100. Bring the 16 over, make it negative. That will leave you with the square root of 84. And the square root of 84 is 9.2. So the height would be approximately 9.2. Alright, so for the h right here, we're going to put 9.2. And here we go. 1/3 times 3.14 times 16, 4 squared is 16, times 9.2. And the answer I'm getting is 154.069. I'm checking it now in the book, and they're getting 154 also, just like us. So the answer is 154 centimeters cubed, because you're dealing with volume. Alright, moving on to number 22. And once again, we have a cone, and we're going to find the surface area and the volume of this cone, okay? So I'm going to go ahead and copy these formulas over again. Let's see if we work here, guys. My pen is really giving me fits here today. There we go. And there we go. Alright, and moving on. So let's go ahead and find the surface area of this cone. Of course, it's 3.14 times the radius squared, 6 squared, plus 3.14 times the radius, which is 6, times the slant height, which is 8. This is kind of deja vu. It's kind of the same thing we just did, but we'll go ahead and finish the problem. So we have 3.14 times 6 times 6, 36, which would give us 113.04, plus then 3.14 times 48, because 6 times 8 is 48, would give us 150.72. Now let's add these two numbers together, and we're going to get 263.76 surface area, so square inches. Alright, and the answer to that is 263.9, so close enough. Now let's find the volume of this cylinder. So the volume is 1/3 times pi, which is 3.14, times radius squared. Of course, the radius is 6, and then we're missing again the height. So I've got my nice, pretty right triangle right here. This bottom side right here is 6. The hypotenuse right here is 8. Because if this length over here is 8, then this length right here would also be 8. Alright, so we're looking for this height right here. We can use Pythagorean's theorem very quickly. I'm not going to take time and do that for you, but if we use Pythagorean's theorem quickly, we would get, let's see, 3. Actually, I have to work this out. I think I can do it in my head, but I don't think I can. So here we go. We have a leg squared plus a leg squared equals hypotenuse squared. So x squared plus 36 plus 64. Now subtract 36 from both sides, and we're left with, let's see, is it 28? Is that correct? I think that's right, 28. And then take the square root of 28. Take the square root of both sides, and the square root of 28 would be 5.3. 5.3 for the height. Okay, so I'm going to take 1/3 times 3.14 times 36 times 5.3, and I'm getting 199.704, and they're getting 199.5, so we're definitely close enough. 199.7 inches cubed. We're dealing with volume. Alright, moving on to number 23 through 28. looks like we're just doing matching, so here we go. A sphere. Let's see what we have here. A set of points of a given distance from a center point, letter D. That would be sphere, letter D. For radius, or 24 radius. A segment, let's see. Here we go, letter F. Segment whose endpoints are the center and a point on the sphere. That would definitely be the radius. If you have a segment who has a point or an endpoint on the center, at the center of the sphere, and an endpoint on the sphere, that would be the radius. Now a chord is a segment whose endpoints are on the sphere. Any segment at all that you draw. Here's a sphere. A chord would be a line simply that goes from here just to right there. That's it, that would be a chord. Any segment whose endpoints lie on the edge of the sphere is going to be called a chord. Alright, letter B. Alright, segment whose endpoints are on the sphere. Now number 26, the diameter. Well guys, the diameter is a chord that contains the center of the sphere. Think about it. A diameter is simply a chord. That means it goes from endpoint. That goes from edge of the sphere to edge of the sphere. But it has to contain the center of the sphere. In other words, the line, the chord that you draw from the edge of the sphere to the edge must pass through the center, and that would be the diameter, which is letter E. 27, the great circle. Well, you get the great circle when letter A happens. Intersection of a plane through the center of a sphere. And then lastly, hemisphere would be half of a sphere bounded by a great circle. A hemisphere is half a sphere bounded by a great circle. Alright, and that would be letter C for hemisphere. Alright, moving on. Students number 29 reads, find the surface area and volume of a sphere with a 14-meter radius. Find the surface area and volume of a sphere with a 14-meter radius. Now, the first thing we need to do is get the two formulas up here for surface area and volume. So there they are. Now, let's go ahead and start with surface area right here. 4 times 3.14 times the radius squared. Now, the radius is 14. So 14 squared. So quickly grabbing my calculator here, so I have this thing correctly here. Let's see here. I'm getting 2,461. Let me turn over to the correct page so I can check my answer. 2,461.76. Yep, and that is correct. 2,461.76 square meters, because we're dealing with area, surface area. Now, the volume of a sphere is 4/3 times 3.14 times the radius to the third power, so 14 to the third power. So, typing all of this into my calculator, I'm going to get 2,000,000. Now I wonder if this could be correct. I think I hit something wrong here. Yeah, it doesn't sound right, so let me try this again. 4/3 times 3.14 times 14 to the third power. This time I'm getting, yeah, that's the right answer, 11,488.213, repeating, meters cubed, because we're dealing with volume, okay? That's pretty simple. Just find the volume and surface area of a sphere. Number 30, we're going to do it again, it looks like to me. So let's go back a page. Let's grab these two formulas here. And let's see if we can't move them over to the next page. And here we go. We're going to find the surface area and the volume of a sphere who has a half an inch radius, so pretty small, a half an inch radius. So let's see what we can come up with on this. Here we go. 4 times 3.14 times the radius, which is 0.5. Alright, grab my calculator. I'm going to type all of this in, and let's see what we come up with here. And it should be what? R squared, by the way. There we go. I'm getting 3.14 inches squared for the surface area, and that is correct. 3.14 inches squared. Now for the volume of this sphere, this should be what? 4/3. So 4/3 times 3.14 times the radius, which is 0.5, to the third power. When you type all of this into your calculator, we're going to get